Hi everyone, Ms. Colasso here. So in this video today, I'm going to walk you through the Mutations Lab 2.4.3 on Apex. So in this lab, you are given a sentence that looks like this. And so what you're going to be doing throughout the first few questions is really just manipulating the sentence. And the sentence is going to represent DNA. So these would be our bases, each letter, and the groups of three would be our codons. So now what I'm going to do is kind of walk through the first few steps and explain how it relates to DNA. So this is the first sentence that they're going to give you, and then they're going to ask you to group it into pairs of three. So 3 letters in each group. So I'm just going to write that out and show you what it looks like. So we have the space, fat, space, man, Okay, so then that would be the second sentence you're going to do. You're just going to add spaces. So now each pair of 3 is going to represent our codons, right? So that's how it's similar to DNA. And now this is our sequence. So we have it in groups of 3. So 3 letters per group. So now it's going to ask you, does this sentence make sense? Well, yeah, the fat man was too big for the red car, but the cat was not. So you would say that it is coherent. That is a coherent sentence. So coherent just means that it makes sense. So now it's going to say, all right, well, we're going to replace the C with an H. So instead of rewriting this, I'm just going to make that change, right? So we're getting rid of the C and putting in an H. So now we read it again. The fat man was too big for the red car, but the hat was not. So does this still make sense? Absolutely. So you would say that it makes sense. The change was not significant because it still makes sense. And this is what would be called a silent mutation. So silent mutations still make sense even though there is a mutation. So it's still going to read just as it normally would, and the way it's translated really doesn't, or really isn't affected by the mutation. Okay? So now the next thing that you're going to do, and I'm just going to switch my colors, is you are going to switch out all of the N for F and all of the B's for K's. So I'm going to do that now in this one. So we're just substituting letters. So the fat, so I'll underline the letters that I changed. So remember, we're still keeping it in groups of 3. That's supposed to be K. So we'll keep the hat was okay. So we just replaced. We replaced the N's with F's and the B's with K's. So this would be a substitution. Substitution. Does the sentence now make sense? The fat math was too kig for the red car, cut the hat was fought. No, it does not make sense. So this would be a missense. So that would be a missense mutation. It does not make sense anymore. So this is what actually could happen to our DNA if there's a mutation. So now this would not be translated to the proper proteins, and that could actually have a negative effect or cause like a very visible mutation. So the last thing that you're going to do with this sequence is you're going to do a frame shift mutation. So you're going to delete the first T and shift all of the letters over so that you're still in groups of 3. So now this is probably the most confusing part, and I'm just going to add a little paper at the bottom in case we need the space. So I want you to pay attention closely. So we're deleting the T, so right away we're going to start with H-E. Now remember, we want to keep it in those codons, groups of 3. So now we have to bring this F over so that it is still in a codon in a group of 3. So H-E-F, and then you're just going to transfer it over. So A-T-M. Then we have A-F, move over the W, A-S-T, O-O-K, I-G-F, O-R-T, H-E-R, E-D-C. So it looks like I'm going fast, but you could rewatch this and take it a little slower if you need to. And then we have OT at the end. Okay, so now does this make any sense at all? Absolutely not, right? So this is what happens when there is a deletion of a base and a frame shift. So this would be deletion. So there was a deletion of the T, the first one, and a frame shift, where all the letters switched places, right? They all switched over. So see how we've only had a few mutations here, and look at how it went from making sense to making absolutely no sense. So that's what could happen with mutations. So it's going to ask you how this is similar to DNA, and that's what we've been talking about. So we know that there's going to be groups of 3 to represent our codons, and that with each mutation, the sentence or the sequence, right? So let's say this is a DNA sequence, is going to change each time. Okay, so I hope this helps with this problem. Let me know if you have any questions, all right? Thanks, guys.